Welcome back to another edition of 8-Minute Math, where the goal is that we teach you the concept in approximately 8 minutes. Today's topic is called Solving Systems of Inequalities by Graphing. Before we begin, I would suggest that you pause the video just to look at the concepts that are written on this slide. These are some of the things that I am assuming you are already familiar with before the video even begins. So here we go. Before we get to some examples, let's quickly review how do we graph an inequality. For example, y is greater than 2x minus 1. Well, let's think back to slope-intercept form, y equals mx plus b. The slope would be 2, that is the value of m, and then the y-intercept is negative 1, that is the value of b. We would plot b first, that is at 0, negative 1, the blue dot you see right there, and then in order to do the slope, well, it does say 2, but we want to think of that as 2 over 1, which goes along with the concept of rise over run. We go up 2 units, 1 unit to the right, and that gives us our next dot that we can then draw a line through. Now, I talked about an example just now where we graphed it as a line, but really this is an inequality. So there are a few other rules that come into play. Something you need to know. If the inequality symbols are the ones that say greater than, you will be shading above your line. If your inequality symbols are the greater than or less than sign, so notice how there is no line beneath those, that means your line will be dotted or dashed. And then if you have any of the or equal to symbols where the line is beneath them, your line will be solid. In this case, we have the greater than sign, meaning we will have a dashed line. And then because of the greater than sign, we will be shading above our line. And this is how you graph a single linear inequality. So let's get into what we are going to be doing today, where two inequalities that make up a system of inequalities will be graphed. If you think you already know what to do, feel free to pause the video. I will go over the example as soon as you hit resume. All right, here we go. The first inequality will be done in the color blue. Again, I am assuming we are already familiar with slope-intercept form and how to graph lines. The y-intercept is negative 1, so there is a dot at negative 1. The slope says 2, but we're going to change that to 2 over 1 so that we can do rise over run, going up 2 units and then 1 unit to the right. And then we put our line through those dots. Because it says one of the or equal to symbols, the line will be a solid line. Because it says greater than or equal to, we shade above the blue line, and now we have half of the problem done. What makes this problem different from the example that I just showed you, we now have a second inequality that we're going to graph. That will be done in the color red. The y-intercept is positive 1, so we put a dot at plus 1. The slope is negative 1 over 2, so we have to rise down 1 unit and then go 2 units in the positive direction to the right. Because it says the less than sign, we're going to have a dotted or dashed line. And because of less than, we shade underneath the red line. Now take a moment to notice the blue and red shaded regions are both there, but they overlap in this area that is now highlighted in yellow. Where the two shaded regions overlap is your solution set. That is the answer that you would highlight, and that is how you do these problems. Here are a few more examples. I encourage you to pause the video, try it on your own, and then hit resume when you are ready. All right, next example. You will notice, and we'll do this in blue again, you will notice that it just says 2/3 x, but there's no y-intercept printed there. That means the y-intercept was 0. It is okay to have a y-intercept of 0. 0 represents nothing, and you did not see a y-intercept there, so that means it had to have been 0. The slope is 2/3, so that means we go up 2 over 3 to the right. It says the greater than symbol, so that means the line is going to be dotted, and we shade above because of the greater than symbol. The second inequality will be done in the color red. The y-intercept is a positive 1, so we put a red dot right there at positive 1. The slope is negative 3, but we're going to change that into negative 3 over 1 to go along with rise over run. Go down 3, 1 unit to the right, and then we put a line through those two dots, and that line is solid because of the less than or equal to symbol, which is also why we would shade underneath the red line. This is below the red line. Where those two shaded regions overlap is your solution set, and that is it for example 2. Here's the next example. Feel free to pause, resume when you're ready. And okay, these are some of the special case inequalities that you might run into from time to time. Notice how the first one says x is less than or equal to 2. These are very easy to graph. All you do is, because it says x is less than or equal to 2, you go to the x-axis and put a dot on the number 2. Every single inequality that involves just the letter x is going to make a vertical line every single time. Let's go ahead and do the second inequality though. It says y is greater than negative 2. Every single inequality that only involves the letter y will make a horizontal line. X inequalities make vertical lines, y inequalities make horizontal lines. And notice on the y-axis, we put the number 2 there, negative 2 there, and we drew a horizontal line through it. Now, I graphed these two lines first just to demonstrate that kind of extra concept that goes along with it. Let's now do the shading. The first inequality says x is less than or equal to 2. Usually less than means you shade below. But because we have a vertical line, there really isn't a above or below. You have to think about left or right. It says less than. Where are the numbers getting less or smaller? To the left side of the graph. Whenever you're shading a vertical line, less means left, greater would mean more, and you would shade on the right side. But we have the shading right over here to the left side of the blue line. The red inequality for y says greater than, so we shade above the red line. Where these two areas overlap is our solution set. Final example. Pause the video, resume when you are ready. And here we go. Really quick. The first one will be done in blue. The y-intercept is negative 1. The slope, it says negative x, which really means negative 1. And in rise over run form, that is negative 1 over 1. So we go down 1, 1 to the right. We draw a solid line through it because of the greater than or equal to sign. And now let's do the other inequality. Notice how it said negative 1/2 x. There is no y-intercept there. So we put a dot at 0 because really it would have said plus 0 after that x right there. Then the slope is negative 1/2. That negative sign can go either with the 1 or the 2. It doesn't matter. So we'll go ahead and put it with the 1, making the rise negative 1 and the run positive 2. Once we draw our dotted line through those dots, because it says less than, we are now ready to shade. Greater than means we shade above the blue line. Less than means we shade below the red line. And where these two areas overlap is our solution set. I hope this video has assisted you in understanding how to graph systems of linear inequalities. I will see you guys next time. Bye.